In the last few lessons, we wrote our networking code to fetch the weather data and pass the JSON response from OpenWeatherMap. Then we created our weather model to hold on to our weather data. In this lesson, we're going to tie it all together by writing the code to pass the weather information back to the weather view controller. And to do that, we're going to use delegates and protocols. Speaking of protocols, sometimes more than one protocol can be combined under a single name. Now, notice how we're using the decodable protocol here. If you needed to be able to encode data back into JSON format, then you could also tag on another protocol, which is the encodable protocol, which allows your Swift objects to be encoded into a JSON. Now, in order to save people time, they actually managed to create something called a type alias that combines these two protocols, and it's called codable. So when you see code out in the wild that have this thing codable that's added at the end, when you click on it, you see that, oh, it's a type alias. What does that mean? Well, all it is it just combines two protocols into one, and we can add them both in one go. So that's something to be aware of. Now, coming back to our parse JSON method, once we've created our weather object from our weather model, I want to be able to return it to the place where I called parse JSON. So that way I could, for example, say let weather equals self.parseJSON. And to do this, I of course have to provide an output to this method. And it is going to be the weather model data type, because that's what our weather is created from. So how do I output this? Well, I could simply just return weather right here that I've created from the data that I've parsed. But what if the parsing didn't go according to plan? What if we ended up with an error? What if this decoding process failed? Well, in that case, it would actually skip all of these lines of code and go straight to the catch block and print our error. Well, at this point, then, we're not going to get anything returned, and our output is no longer being provided. So that's why we're getting this error, missing return in a function expected to return weather model. So what can we do? Well, we could, in the catch instance, simply return nil, because we don't actually have a weather object to return. We didn't manage to successfully decode the data. But in order for us to be able to set something as nil, well, then our weather model has to become an optional. So now we have this optional coming out of our parse JSON method, and this is now an optional weather model. But of course, we want to be able to use it, so we can simply optional bind the weather object that comes out of parse JSON as the output to something called weather. Now we can use this weather, which is an unwrapped weather model object. What do we want to do with this weather object? Well, we want to send it back to the place where we need it, which is the weather view controller. We want to use the condition name to populate the condition image view. We want to be able to put the temperature into the temperature label. So how do we get it back into the weather view controller? Well, one way that we could do this is to create a weather view controller object from our weather view controller, and then inside our weather view controller we could create a function called did update weather, and we would be able to pass in the weather model object as the weather. And then inside here we should be able to then print weather.temperature. And then going back to our weather manager, then we would call weather vc dot did update weather, and then we would be able to pass in this weather object as the input. Now that would work, but if we come back to what we learned in our delegates and protocols lessons, by doing this, we would basically render our weather manager single use. It would become like a plastic cup or a plastic tray. We have to limit its use to this current project. But in a future project, if we needed to get weather data, well, we could reuse this struct weather manager. And the way that we would do that is by not using any specific code in it that ties it to another object, say the weather view controller. So we could solve this problem by simply using a delegate pattern. We could say something like delegate, if it exists, call did update weather. And inside the did update weather, we would maybe have a input called weather. And then here we could pass in this weather object that we got back from our parse JSON. So here's my challenge to you. I want you to write this line of code exactly where you see it here inside the iflet that unwraps the weather object that we get back from parse JSON. And we're going to try and pass this weather object back to the delegate. And the delegate is going to be our weather view controller. So that's going to be the class where we're going to trigger this method did update weather. But we're going to do it using the delegate design pattern. That means that in our weather manager, we would need a variable called delegate, and this should have the data type of weather manager delegate, and it will be an optional, so that whoever or whichever class or struct sets themselves as the weather manager delegate would have to have the implementation for this method did update weather, so that we can actually call delegate did update weather and pass over the weather that we have in our weather manager. And it should be able to land in our weather view controller. And we should be able to print out the temperature property of the weather. Pause the video now and see if you can complete this challenge that tests your knowledge of delegates and protocols. All right, the first thing we need to do is to create our protocol. So right up here outside of the weather manager, and remember that by convention in Swift, we create the protocol in the same file as the class that will use the protocol. In this case, the protocol is going to be called a weather manager delegate. So this is the name that we specified earlier. And then the requirements are that you must be able to implement a function called did update weather. And the inputs are called weather, and it has to be of type weather model. These are our requirements set out. So now we set our delegate as a optional weather manager delegate. So if some class or some struct has set themselves as the delegate, then we would be able to call upon the delegate and tell it to update the weather. Now, remember that because we're inside a closure, our delegate has to have the keyword self in front to make it clear that we're referring to the delegate in the current class, which is this one right here. So now we have to go into our weather view controller and adopt that weather manager delegate. And as soon as we do that, right now we're not actually getting errors because we already have implemented the method which is called did update weather, because this is the requirement of that protocol. So adopting it, we have to have this. But because it already exists, we don't get any errors. But what we do have to do, which I often forget, is we do have to set this current class as the delegate. So we have to say that the weather manager dot delegate property is equal to self. That way, our weather manager's delegate property is not nil. And then down here where we call delegate.didUpdateWeather, weather, this optional chaining here will actually pass through because it's not nil. And then we actually trigger this didUpdateWeather weather and pass over this weather object. So let's give it a spin, see if it works. So now let's search for the weather in Paris again. And you can see that we're getting the temperature sent over. Perfect. We're now adopting the delegate design pattern, and our weather manager is now completely reusable. We could use this in any other class without having to change any of the code inside, and all we would have to do is whatever class that needs this functionality of getting the weather data from OpenWeatherMap, then we would simply adopt the weather manager delegate, set the class as the delegate, and then have the implementation of did update weather to be notified when the weather is available from the internet. This is a good time to mention that there's a couple of conventions that we use when we're adopting the delegate pattern like this in Swift. Notice how in the delegate methods that Apple has created, the way that they're written, they start out with an underscore, and then the parameter name, and then the data type. So why is it that there's an underscore there, and why is it separated from the name of the text field? This is because in Swift, we can have something called a local parameter name, and we can even omit the parameter name when we're calling the method. To find out more about this, you can head over to the next lesson where we're going to do a deep dive on parameter names for Swift methods. If you already know all about this, then feel free to skip the next lesson where we continue building out our project and formatting our delegate methods.